Welcome to this class. Today I'm going to continue the chapter Wave of class 9 and the subject is Science and Technology and it is taken in unit number 10. And today's focus is on transverse wave and longitudinal wave, and after that I'll talk about different terms related to the wave. But before the transverse and longitudinal wave and different terms related to the wave, I want to recall the previous matter. What I mean to say, what is wave? What are the types of wave? First, we recall about this matter and then we'll enter into transverse and longitudinal wave. Okay, what is wave? In previous class, what I told you, the wave is a periodic disturbance that transmit energy. What it mean? Periodic disturbance means what? When a source moves this way from mean position to extreme position of one side and again comes back to mean position and goes to extreme position of another side and again comes back to mean position. This way, if a particle or if a source keeps on moving, this is called periodic motion. Or maybe like this, forward, backward, forward, backward. It lives in its mean position and moves forward and goes to the extreme position of the front side and comes back and goes to extreme position of back side. In this way, if a particle or a source or anything, if moves this way or this way or this way, the periodic motion, it means this is periodic motion. And when a source moving in periodic motion disturbs the particle of the medium means if it is moving in air, suddenly it disturbs the particle of the air. If it is moving in water, suddenly it disturbs the particle of water. This way, if periodic disturbance is produced in the particles of the medium, then wave produces. Wave means carrier of energy. It carries energy from one place to another place. If there is no medium, even then the wave produces and it carries the energy from one place to another place. That's why we can say that this is the periodic disturbance. The object is periodically disturbing the surface of water. That's why ripple of water is being produced. This is water wave. And this water wave carries energy from this point of disturbance to the edge of this pond. This is periodic disturbance produced by a vibrating body. If there is no medium, let's talk about light wave, let's talk about heat waves. Heat can come from sun to the earth, light can come from sun to the earth in the wave motion, in the form of wave motion. At this time, there is no medium in between sun and the earth. Even though this wave travels, it means wave can travel without the medium also. At that time, we can define this way also. Wave is carrier of energy. It carries energy from one place to another place, whether there is medium or not. Okay, now the wave is divided into two types. What are they? One is called mechanical wave and another is called electromagnetic wave. Now I want to go through mechanical wave. What it means, mechanical wave? Mechanical wave can be defined this way. The wave which requires material medium for propagation is called mechanical wave. The wave which requires material medium, mind it, this is the key point. If wave travels through a medium, then this is mechanical wave. Now we can take one example, how mechanical wave produces. Okay, this is a vibrating speaker. When a speaker vibrates from mean position to extreme position and comes back to mean position, goes down, and this way speaker is vibrating. If a speaker is vibrating, certainly it produces disturbance in the particle of the air. Particle of the air cannot be seen. I am showing this with the help of the dot marks. Hundreds of dot marks are made here to show the particle of the air. When vibrating speaker vibrates the particle, then what happens? Particles are pushed forward and pushed particle takes energy and it transfers that energy to another particle. Energy is handed over to another particle and it comes back. The second particle, which takes energy, it moves forward and it hand over the energy to third particle. This way, particle to particle energy is handed over and energy transmit from this central part to the outer direction. It means this transmission is possible because of the vibration of the particle, and these particles are vibrating to produce wave. If you see this very carefully, you can understand this. Each and every particles are just moving forward and backward, forward and backward. They are not moving far away. They are moving just forward and backward. But the energy is moved away from this central part, which is the wave. Wave moves away from the central part. Particles are moving forward and backward only. This is mechanical wave. And we can describe this shortly this way. It is a form of disturbance that produces repeated periodic motion on the particles of the medium about their mean positions, and the disturbance is handed over from particle to particle, due to which wave produces and travels through the medium. This is the mechanical wave. We are taught a little in previous class also. Now, I want to talk about second type of wave, which does not require any material medium to travel. What is this? Electromagnetic wave, as I mentioned previously. What is it? The wave which travels in the form of electric and magnetic field and does not require the material medium to travel is called electromagnetic wave. Look at this carefully. The wave which travels in the form of electric and magnetic field. What is it? Electric and magnetic field produces because of the charged particle, motion of the charged particle, which we will learn in detail in class 10. But now I want to tell you just the charged particle are if moving, then electric field and magnetic field produces. And what is the definition? The wave which travels in the form of electric and magnetic field and does not require any material medium, without the material medium, is called actually electromagnetic wave. How to understand this? I want to present one animated video. Look at this. This is electromagnetic wave. This is the source from where electromagnetic wave is being produced. Produced at this place, and how it is traveling? It is traveling towards this direction. The direction of wave is this. This is the direction of wave. But this red part of this wave represents electric field, and this blue part represents magnetic field. And electric field and magnetic field are right angle to each other. They are perpendicular to each other. Not only that, they are changing their position periodically. Within fraction of second, the region where red part appeared, I mean to say electric field appeared, is taken up by the magnetic field, blue part. This way, this magnetic field and electric field produces this way perpendicular to each other. One is perpendicular to each other, and they are changing their position this way within fraction of second, and wave is traveling in this direction. These electric and magnetic field are normal to the direction of propagation of wave. We'll talk in detail about the electromagnetic wave in next class. At this time, just the definition, just the identification only. Now, how can we say about this? It is the wave produced by the mutually perpendicular and periodically varying electric and magnetic fields in a plane normal to the direction of propagation of wave. This is the definition of electromagnetic wave. Okay, I finished a little about the electromagnetic wave and mechanical wave. Let's come back to the same chart. Mechanical wave and electromagnetic wave. Mechanical wave is further divided into two types. One is called transverse wave, another is called longitudinal wave. But electromagnetic wave is divided into 7 different parts, which are called electromagnetic spectrum also, and it starts from radio wave, microwave, infrared rays, visible light, ultraviolet rays, X-ray, and gamma ray. Just 7, not more than 7, not less than 7. Electromagnetic wave is further divided into 7 different types according to the frequency and wavelength. And we'll learn in detail about this electromagnetic wave in another class. But today's focus is on transverse wave and longitudinal wave and the terms related to the wave. Okay, let's talk about transverse wave. I want to tell you something about the transverse wave with the help of this diagram. Let's say this line represents the surface of water. Surface of water. This line represents the surface of water where the wave is produced. This way wave is produced. Let's say this way wave is produced. I mean to say this is the ripple of water. And this is the wave. If this point is disturbed by using certain stone, throwing a stone, if this point is disturbed, then ripple of water produces in all the sides. And this mean position, this is called mean position of the wave also. And at this time, what is happening actually? The particle at this place, previously particle present at this place is moved to this point. Particle which was previously present at this point is moved to this point. And particle previously present at this point is moved to this point. And another this way. Look at this, very easy to understand. Particle which were previously present at this position is moved to this part of the wave. And when it reaches to the extreme position, then it comes back to its mean position again. And at this point, the particle moves down. At this point, particle moves down towards the mean position. This is the mean position. And at this point, the particle of this point moves down. In the same way, here, the particle of this point moves downward, and this point also moves downward, this point also moves downward, and somewhere it reaches to the maximum displacement at this point. Look at this. And after reaching to this extreme point, it comes back to the mean position this way. This diagram makes you very clear about the vibration of the particle of the medium. Okay, I don't want to draw anymore. Look at this. These particles are moving up and down. I mean to say these 4 particles I'm showing here, 4 particles move to this part of the wave. And remaining this particle, 3 particles are moving downward. And again, the particles are moving downward from mean position. And again, it is moving upward. What is the conclusion? Conclusion is very simple. Particles are moving up and down only. Yes, you have to notice this. Particles are moving just up and down only this way. Some particles are moving up and some particles are moving down. The same particle moves up and down only. But wave is traveling towards this direction. Wave is moving towards this direction. Ripple of water moving towards this direction, carrying energy from this place to that place. What is the meaning? Particles of the medium are vibrating perpendicular to the direction of propagation of wave. This type of wave is called transverse wave. What type of wave? When particle moves perpendicular to the direction of propagation of wave, then that type of mechanical wave is called transverse. I can show this with the animated video also. Look at this. This is the wave, what I made just before on the board. Look at these particles carefully. There are many particles, but I want to show you very clearly with the help of these red particles of the water. This red particle is moving just up and down only. Have you noticed this? They are not moving towards this direction. They are moving just up and down. Not only rate particle, all the particles are moving just up and down, but wave is traveling towards this direction. And this type of wave is called transverse wave. Now, how to define? This way. A mechanical wave in which the particle of the medium vibrates perpendicular to the direction of propagation of wave is called transverse wave. For example, wave produced on the surface of water is transverse wave. This is the example of transverse wave. Wave produced on the surface of water, which we see in the form of ripple of water, transverse wave, carries energy. Now, we can understand this with the help of a spring also. Look at this. A spring is not transverse wave. Don't be confused. This slinky coil is used to show the transverse wave and longitudinal wave, but this coil or this spring itself is not transverse wave, not longitudinal wave. With the help of the motion of this spring, we can understand transverse and longitudinal wave. Look at this end is gone up and down. It is moving up and down like the particles of the medium moving up and down. When the particles of the medium moves up and down, then the wave travels in this direction. It is shown by this motion of this spring. This way, transverse wave can be understood. Direction of propagation of wave is this, towards right hand side. Particles are moving up and down. It can be understood practically by this way also. If we have stagnant water or water surface is if not disturbed, if you touch it, then the wave produces, the ripple of water produces, which transmit towards different direction. This way, if we repeatedly disturb the surface of water, then ripple of water produces. This is transverse wave. Wave is traveling towards different direction. It can be understood by this way also. Look at this. This is pizza. Pizza is moving up and down in water, and someone is watching this. Actually, ripple of water is moving away, but the pizza is moving up and down. Why? Energy is traveling towards this direction, away from this pizza, but pizza is moving up and down along with the particle of the water. Particles are moving up and down, that's why pizza is moving up and down, but wave is moving towards horizontal direction. This way, particles of the medium vibrate perpendicular to the direction of propagation of wave. This is transverse wave. Can be understood again and again by this wave also. Okay, now let's stop transverse wave. Now I want to tell you about the longitudinal wave. Now let's go through example. Let's say these are the particles of air. Particles of air cannot be seen, and that's why it is very problematic to understand the longitudinal wave. That's why, to make you very clear, particles are here represented by black dot mark. Certain source, this is the source which is taken as red object. It is moving forward and backward. It has periodic motion, forward and backward, back and forth motion. The source is moving forward and backward. When it moves forward, then it pushes the air particles forward, and pushed air particle moves forward and comes closer to the other particle. And this region where they come closer to each other is called compression. Where the particles of the medium comes closer to each other is called compression. And in this compression, pressure of air will be high, density of air will also be high. Why? Because particles comes closer to each other at this compression. And actually the particles are moving forward, and it hands over the energy to other particle and comes back. And again, the second particle moves forward and it hands over the energy to another particle and comes back. This way, the particles have back and forth motion, forward and backward, forward and backward. If you see very carefully, you can understand very clearly that particles are moving just forward and backward, back and forth motion of the particle. But because of this back and forth motion, particles of the medium somewhere comes closer to each other, which is called compression, and somewhere they are away from each other. Here they are away from each other, and this region is called rarefaction. Rarefaction is the region in which particles of the medium moves away from each other. Pressure is less, density of the particle is also less, but compression has high pressure and high density. And this way, longitudinal wave travels in the form of compression and rarefaction. This compression followed by rarefaction, again followed by this compression, and this compression is again followed by this rarefaction. Actually, longitudinal wave travels in the form of compression and rarefaction. Now, let's come back to the motion of the particle and direction of the wave. Wave is traveling towards this direction, right inside, and particles are moving along the direction of propagation of wave. Back and forth motion means in which direction wave is traveling, it is vibrating in the same direction. Looking at these rate points, you can understand these rate points which are seen in this air, it is moving forward and backward, back and forth motion, but energy is handed over and traveling. This way longitudinal wave produces. We can understand this way also. The compression is if the peak position of this wave, then rarefaction can be taken as the downward peak position of the wave. This way, longitudinal wave travels, and it can be understood with the help of a spring also. Look at this. This spring itself or slinky coil itself is not the longitudinal wave. When it is moved forward, then we can consider that when it is moved forward and backward, then particle of the medium is moving forward and backward. We can consider this way. At this time, what is happening? The compression moves forward and it is followed by rarefaction if we continuously move. This way, direction of propagation of wave is this, left hand side. But direction of vibration of particle is also the same. That's why longitudinal wave can be defined this way. A mechanical wave is called longitudinal wave if the particle of the medium of the wave vibrate along the direction of propagation of wave, not perpendicular to the direction of propagation of wave, along the direction of propagation of wave. We can compare these two. Transverse wave, particle moving up and down, wave moves right hand side, and here particles are moving along the same direction, forward and backward, wave is moving towards right hand side. This way we can compare. Okay. This is all about the transverse and longitudinal wave. Now, I want to differentiate mechanical wave with electromagnetic wave. What is mechanical wave and how it is different than electromagnetic wave? First, we can say thus the definition says that it requires material medium for propagation. What? Mechanical wave. But it doesn't require material medium for propagation. Second difference is mechanical wave is either transverse or longitudinal wave, but it is transverse in nature. What is transverse in nature? Electromagnetic wave is always transverse wave. Now third is mechanical wave are produced by the vibration of the particles of the medium, but electromagnetic waves are produced by the changing of electric and magnetic field. I showed this in the previous animated video. And this speed of the mechanical wave is normally less than electromagnetic wave, but the speed of the electromagnetic wave is greater than mechanical wave. Actually, electromagnetic wave moves with the velocity of light. Okay, now let's talk about different terms related to what wave. Now I want to enter into different terms related to the wave. What are these different terms? Let's talk about them one by one. I want to come back to this diagram and I want to show you different terms. Look at this. This line represents the mean position of the wave. What is this? Mean position. Mean position. What it means? Mean position means when wave was not produced at that time, the particles were present in this line. And this is called mean position of the wave or mean position of the particle of the medium. And this part is called crest. What is this? The part of the wave which formed above the mean position of the wave is called crest. This is crest. The whole part is crest, but the extreme position of crest is this. The part of the wave which formed below the mean position, this is the mean position, and this part of the wave is called trough. This is trough. This is crest. This is trough, and this is the mean position of the wave. And look at this again, a complete crest and a complete trough. This is a complete wave. Here we have two complete waves. I told you about 4 points. One, mean position, another crest, another trough, and complete wave. What it means? Okay, I want to show the definition also. Mean position means the initial position of the particle of the medium before vibration is called mean position of the wave. But what is crest? Crest, the part of the wave formed above the mean position of the wave, is known as crest. And third, trough. What is trough? The part of the wave formed below the mean position of the wave is known as trough. And what is one complete wave? A wave having a complete crest and a complete trough. A complete crest and a complete trough is known as one complete wave. One complete vibration of the particle of the medium produces one complete wave. What is the meaning of this saying? One complete vibration. If a particle is in this position, it moves upward and goes to extreme position and comes back and goes to downward extreme position and comes back to mean position. This is one complete vibration, up, down, and again came back to mean position. From mean position up, down, and again came back to mean position. One complete vibration. It can be understood this way also. There's a mean position and forward, extreme position, came back and gone to extreme position of another side and again came back. This is one complete vibration. And when one complete vibration occurs, then this is called one complete wave also. Now, let's talk about other terms also. Look at the diagram. This is the maximum displacement of the particle of the medium. This particle of the medium displaces maximum to this height from the mean position. And it can displace to this depth from the mean position. And this maximum displacement of the particle of the medium is called amplitude. And it is denoted by A, and it is physical quantity and its unit is meter. What is amplitude? The maximum displacement of the particle of the medium is amplitude. Now we can define amplitude this way. The maximum displacement of the particle of the medium of wave on the either side of their mean position. We can take this also or this also, both of them are equal. We can measure this or this, both of them are equal. And that's why what I mean to say, the maximum displacement of the particle of the medium of the wave on the either side of their mean position is called amplitude of that wave. It can also be defined this way, the maximum height of the crest. This is the maximum height of the crest. The maximum height of the crest or maximum depth of the trough. This is the maximum depth of the trough. Maximum height of the crest or maximum depth of the trough can be considered as amplitude of wave. Its SI unit is meter. Okay, now let's talk about the frequency. You have seen that here we have two complete waves. How many complete waves are produced in 1 second? That represents the frequency. The number of complete waves produced in 1 second. Look at this. If we have two waves in 1 second, then frequency will be 2 and its unit is hertz, or we can say cycle per second, which is taken as hertz, H-E-R-T-Z. In the name of the scientist, its symbol is Hz. Okay, let's define it. What is frequency? Frequency, the number of complete vibration made by any particle of the medium of wave in 1 second is called the frequency of wave. We can define the same in this way also. The number of complete waves produced in 1 second is known as the frequency of wave. It is denoted by symbol F. Its SI unit is Hertz. There are two methods of defining frequency. If this number of vibration is 2 in 1 second, 2 Hertz, number of vibration means mean position to extreme, again mean comes back to mean position and goes to extreme and again comes back to mean position, 1 complete vibration. And how many complete vibrations are produced in 1 second, that represents the frequency of that wave. Okay, now let's move forward. Another term, wavelength. What is it? Wavelength. Look at this. This is the extreme point of this crest, and this is the extreme point of another neighboring crest, successive crest. The distance between the extreme point of two successive crests, this distance, the distance between extreme point of two successive crests or the distance between the extreme point of two neighboring crests is called wavelength, and wavelength is denoted by the symbol lambda. Wavelength is denoted by lambda and its SI unit is meter. Not only these 2 points, we can take these 2 points also. The distance between the extreme point of two successive trough, the distance between the extreme point of two successive trough also represents the same wavelength and it is denoted by lambda and its SI unit is meter. Now I want to define. Look at this. Wavelength, the distance between two extreme point of successive crest or trough of a wave is called wavelength. Or we can say this way also, or the distance between two successive compression or rarefaction of a sound wave. In the context of sound wave, in the context of longitudinal wave, what can we say? The distance between two successive compression to compression or rarefaction to rarefaction. The distance between two compressions or two rarefactions of sound wave or longitudinal wave, sound wave is longitudinal wave, is taken as wavelength of that wave. Okay, now what is its unit? Wavelength is denoted by lambda and its SI unit is meter. Now again we have to say something. I mean to say we haven't finished these terms. There are other two terms. One is time period. What exactly is time period? Time taken by the particle of wave to complete one vibration. How long it takes to move up, down and come back to mean position. Mean position to up, down and mean position. Time taken by the particle for one complete vibration is time period. Or this way and mean position. Mean position to this, back and forth motion. Mean position to extreme, back to extreme and mean position. One complete vibration, how long it takes to complete one vibration is time period. Complete vibration is called time period. It is denoted by capital T, symbolized by capital T and its SI unit is second. We can calculate by using this formula also. Capital T is equal to 1 by F. F is frequency, capital T is time period. Okay, now the last term I want to represent, this velocity of wave. What is it? It is defined as the distance traveled by the wave in unit time. Distance traveled in unit time, this is the normal matter you are taught from class 6 or 7. Velocity is equal to displacement by time. You know about this. The distance traveled by the wave in unit time, which is denoted by V. V denotes velocity. Velocity is just the distance by time. And its SI unit is meter. And it can be represented by formula velocity of sound V is equal to frequency F into wavelength lambda. Velocity is measured in meter per second. Frequency is measured in hertz and wavelength is measured in meter. Some of you might have a little confusion. If velocity is equal to distance by time, how it be equal to frequency into wavelength? Look at this very simple way. Velocity is equal to distance by time. And if I want to talk about the unit only. Distance is measured in meter and time is measured in second. But here in wave, what we are saying, velocity equal to frequency into wavelength. And frequency is measured in hertz. What it mean? Hertz means what? Hz. Hz. Hertz means what? Hertz is just how many times per second? Per second is exact unit is per second, 1 by second. Actually, Hertz means 1 by second. But this wavelength is measured in meter. Now, if we multiply this 1 by second with meter, this meter, then what we get? Meter per second. Look at this, the unit is same. Yes, this is frequency represents how many times the particle vibrate in 1 second, and its inverse second is its unit. And what is the this wavelength? Wavelength meter per second is the velocity. This way we can understand. Okay, now I think I made you very clear about what mechanical wave and electromagnetic wave, what is the difference. And I think now you are very clear about the transverse wave and longitudinal wave also. And I think you are very clear about different terms related to the wave. Okay, in next class we'll talk about electromagnetic wave. Now the time is finished, that's why I want to stop now. Thank you.